Number 1. A total of 165 people contributed to a charity event as either a donor or a volunteer. 130 people contributed as a donor. How many people contributed as a volunteer? If you really wanted to, you could make a little algebraic equation for this. I'm just going to write it out in case that helps people visualize it. So it was 165 people are either donors or volunteers. So the number of donors plus the number of volunteers equaled 165. The number of donors was 130. So how many volunteers? So at that point you can say, I can put in 130 there for D. So it would be 165 equals 130 plus V. And then we would undo what's been done to V by subtracting 130 from both sides, and we would get that V is equal to 35, which is A. Now that's not necessary to do it that way. If you can look at it and just go, okay, if it's donors plus volunteers, so there's 130 donors plus a certain number of volunteers would equal 165. And go, okay, so I need to subtract 130 from 165, and you don't need to write it out. That's fine too. Just I'm writing it out here because that can help some people visualize it that are having a little more difficulty seeing that. But our answer is A, 35. Number 2, there are 250 trees in a park. Of these trees, 6% are birch trees. How many birch trees are in the park? When we say a percent of a number, we're just multiplying. So that would be 250 times 6%. 6% as a decimal is 0.06. So you can multiply this either manually or in your calculator, and you're going to get 15, which is B. If you're interested in doing this in a mental math sort of way, sometimes doing it mentally, once we get those skills down pat, it can be faster, actually, than doing it through a calculator. With practice, it can get faster. So if we're saying 6% of 250, the way I would do this in my head is I would look at 250 as, it's like 100, 150. I know 6% of 100 is 6, because that's the proportion. 6% out of 100% equals what out of 100? It's just going to be 6. It's a very straightforward, proposition right there. So then 6% of this second 100 would also be 6. 50 is going to be half of 100. So 6% of 50 will be half of what 6% of 100. So that would be 3. 6 plus 3 is 15. A lot of times with mental math, a lot of people that do it tend to break the problem apart like this. So they're not in their head saying 250 times 0.06 and multiplying 6 times 250 and then moving the decimal. Maybe some are. If they are, hats off to you. I salute you. But I find that a lot of people that do things mentally find their own method that works best for them and try to break things down into smaller pieces and recombine them in a way that makes sense. Again, if that's a skill that you think you might have or you would like to nurture on things like the SAT where time matters, where every second counts, learning to do things like this in your head quickly can be helpful. If you do choose to do things in your head like this, which I do when I'm taking these tests before I teach them to y'all, I would recommend, if you have time, at the very end, going back and checking those mental math questions with the calculator just to make sure you didn't make a mistake. And I recommend double checking your calculator problems too, if you have the time. Right, number 3, the graph of the quadratic function y equals f of x is shown. What is the vertex of the graph? This is not a calculation problem. This is just a read a graph problem. The vertex of a parabola is either going to be the minimum or the maximum point. It's the point that's the midpoint. You could make the axis of symmetry go straight through it, and you would have two identical parts mirrored. So we're going to look for that vertex on this graph, and that's right here. And it's also happens to be the y-intercept. It can be both. Don't assume it's going to be both. That's unusual. Like say if it was over here, if the problem had been over here, I guarantee you one of your choices down here would have been, that y-intercept, because they want you to think it's a y-intercept. But no, it is not. It's always going to be that vertex down there in the middle. So our vertex here loves putting up notes whenever I try to make a dot because it hates making dots. Whiteboard has that quirk. We look at our coordinates. We do our x first. And so our x coordinate is 0. Our y coordinate is 2. So it is 0, positive 2. And that is C. That's all it is. It's just testing if you can read a graph and if you know what a vertex of a parabola is, where to find that. Number 4, the number of raccoons in a 131 square mile area is estimated to be 2,358. What is the estimated population density in raccoons per square mile of this area? Population density is just saying how things are spread out. It's an average, as it were. Like say if I had 4, come on, let me draw. There we go. If I had a piece of land that was divided into 4 parts, and I said there are 20 raccoons in this area, then you would say on average, I'm guessing there's probably 5 raccoons in each of these spots, right? So how did I do that? I said 20 divided by the total number of raccoons here, the population that's being spread out, and then the total number of sections in that area. So it's your total population over the units like of area. So this is raccoons per square mile, the population of raccoons over the units of area, raccoons per square mile. So what you do is it's nice because they're telling you in the description by saying raccoons per square mile, they're telling you which one goes on top. So it's raccoons per, it means that's what's being divided, square mile. Like miles per hour, that's miles over hours. So raccoons per square mile. How many raccoons are there? There's 2,358. So 2,358. And how many square miles are there? There's 131. So we pop that into our calculator, 2,358 divided by 131. I would not recommend doing that manually. Just put it in your calculator. And we get a 18. If you wanted to do it manually, I'm not going to stop you, but I'm not recommending you do that manually. Just put that in your calculator. I would say if you wanted to do a quick guesstimate, given the 4 answers that are here, 18 is the only one that makes logical sense, even without putting it in a calculator, because we have 131. If I was to multiply this by 10, right, 131 times 10, I would get 1,310. If I multiplied it by 20, it would be twice that, which would get me up to 2,620. So I know, it can't be 131, 149, 2,376. There's no way 131 goes into 2,358 that many times. So in this particular case, honestly, given the answers that are there, you don't even have to put it into your calculator. But it's not like it's that time consuming, so why not just pop it in and then you've got the right answer, A, 18. Number 5, -11, -9, and 26. A data set of 3 numbers is shown. If a number from this data set is selected at random, what is the probability of selecting a positive number? So it's always the part out of the whole. So we're talking probability. What are the odds? What's the probability of this? The total number of options and then the part that we're looking at. So the total number of options, there's 1, 2, 3, and they're telling us again it's a data set of 3 numbers. So the total number of choices is 3. There's 3 numbers that could be chosen if we select a number at random. Side note, if I sound stuffy, I'm sorry. I'm getting over a cold, but I needed to get these videos out for y'all. Couldn't let you all down, so I apologize if I sound a little congested. Okay, as I was saying, we want the part out of the whole. So the positive number is the part we're looking for. How many positive numbers are there? Just one. So that part, that option, there's only one. One option of a positive number out of a 3 total possible options. So that's all we have to do. B, 1 out of 3 is my answer. Number 6, f of x equals 45x plus 600. The function f gives the monthly fee f of x in dollars. A facility charges to keep x crates in storage. What is the monthly fee in dollars that the facility charges to keep 50 crates in storage? Well, they're telling us what all the parts of this equation, as my desk is squeaking weirdly as I write on my computer. That was strange. It's telling us what all of these bits mean. It tells us that the monthly fee is f of x, and it says crates is x. This is the number of crates. So it says if we plug in, because a function is always you plug in an input, you get an output. So here crates is the input, the fee is the output. F of x is your output, always. Yeah, the f of, the g of, the h of, whatever that is, that's the output. So here they're saying, what is the monthly fee that the facility charges to keep 50 crates in storage? If I put 50 in, what do I get? A similar problem might say, what is f of 50? That's another way, this exact same mathematical function, a mathematical task would be a better way of saying it here, that they're asking you to do. It's another way they could ask you to do the same thing. They're just saying plug in 50 right here, do the math, and see what you get. So 45 times 50 plus 600. 45 times 50 is 2250. And then if you add 600 to that, you are going to get $2,850. And that is my answer, $2,850. Of course, you do not have to put the dollar sign when you're putting these answers in, just 2850, 2,850. That is your answer. Number 7, the function f is defined by f of x equals 5 times 1/4 minus x to the power of 2, or squared, plus 11/4. What is the value of f of 1/4? Very similar to the previous problem where I said if they ask what is f of 50, you just plug 50 in. Here, the very next problem, we're getting something just like that. What is the value of f of 1/4? When they say, they give you a function and then they say, what is the value of f of a number? All they're telling you to do is look at your function, and I'm going to rewrite it here. I need to put some WD-40 on my desk. It keeps squeaking. I don't know if you can hear that, but that's not proving too distracting. It's distracting me. So when it's saying this f of 1/4, it's asking you to look at the function as provided, and everywhere there is an x, put this 1/4 in it. That's it. Now, a lot of times when we see fractions, I know I do when I see fractions, we're like, oh, fractions. I'm going to have to be doing some, some like annoying math here. It's going to get kind of in the weeds, but no, not this case, because look at this right here. 1/4 minus, I'm going to plug in 1/4 for x, because that's what I asked to do. 1/4 minus 1/4, that's just 0. So as soon as this becomes 0, all this gets taken out. Because 0 squared is 0, then 0 times 5 is 0. Awesome. 0 plus 11/4. I don't have to do any multiplication of fractions. I don't have to do any conversion of fractions. 0 plus 11/4 is just 11/4. That's it. Don't need your calculator. You can just look at that. I'm guessing some people didn't look at it beforehand and start typing all this in their calculator, but always pays to take a quick glance at it and go, wait a minute, I don't have to waste time doing that. It's just 11/4. As this is a student-produced response, there are 2 ways, and only 2 ways, that you can put this in. You can put it in as 11/4, or you can say it is 2.75. That is 11/4 as a decimal. You cannot put it in as 2 3/4 because it will look like 23/4. You can't do it that way. You will get marked wrong. While in a normal math class with a human, grading your paper, you could put 2 3/4, and that would be fine. It is not fine on the SAT. Don't make that mistake. 2.75 or 11/4 is your answer. Number 8. If 8x equals 6, what is the value of 72x? Now, a lot of times when we have, 8x equals 5x equals 4x plus 3 equals, our first thought is probably to solve for x, and then once we solve for x, plug it into this equation. You absolutely can do this problem this way. I think there's a way that's a little faster. I'll show you that in a minute. But if we were to solve for x and then use it in this equation, we would say 8x equals 6. 8 times x equals 6. We want to undo what's been done since x was multiplied by 8. We want to divide both sides by 8. We get an x on the left, and then 6 over 8, 6/8, or same thing, 3/4, or same thing, 0.75 on the right. That is what x is equal to. And then we can say, okay, 72 times x, so 72 times any one of these. If you want to put it in your calculator, I would say times 0.75. If you're wanting to do it, manually or in your head, I would say times 3/4, because you might say, what is a fourth of 72? Then multiply it by 3. That's definitely a way to do it. There's a lot of different ways that you can do it once you get to that point, but it is just multiplying 72 by x. Now, there's another way to do this. Another way to do it. And here we go. If we start here at 8x equals 6, when you have an equation like this, any equation, you can change it in sort of standard ways. Like when we solved for x, I divided both sides by 8. And you can do that. If you are multiplying or dividing, if you recall from algebra, you can do it by a whole number and everything stays the same. If you're adding or subtracting, you have to do it by a whole term. So I'd have to subtract 8x, like that, okay? But I can just multiply by a number willy-nilly and it will keep it all the same. Right, so what could I multiply this by so that it would be 72x equals something? Well, 8 goes into 72. 8 times 9 is 72. So if I was to multiply this whole equation by 9, I can multiply the left side by 9, and I can multiply the right side by 9. So we'd actually write it more like this, but you get my point. We're multiplying the whole thing by 9. We're not distributing across the equation. I was just sort of sketching that in to convey a thought, not showing an actual mathematical process. So on the left, we would have 9 times 8x equals 72x. Well, what about on the right side? 6 times 9 is 54. 72x is 54. So either way we do it, we're going to get to that same answer, C, 54. A lot of times when the final question is not what is x, a lot of times, not always, but a lot of times when they say, what is the value of, in this case, 72x, or 6x plus 5, or 4x, any variation that is not just what is x, 9 times out of 10, you can manipulate the original equation to get to that endpoint without necessarily having to solve for x. Sometimes it saves you time. If you look at it and you don't think it'll save you time, just go ahead, solve for x. You will get the right answer either way. Number 9. Which expression is equivalent to 23x cubed plus 2x squared plus 9x? When they start asking for equivalent expressions, I am immediately going to look at my answers that they are giving us, because I want to know, are they expecting me to factor this? Are they expecting me to when I say factor, I mean into binomials, like x plus 3 times 2x plus 2, and another x, something like that. Is that what they're expecting? Or, here we go, erase all that. If we look at our answers here, we can see we're left with these trinomials in every single one, and they're just pulling out a single greatest common factor. Oh, okay, well, that's much less scary. Because when you first saw this, you might have gone like, what on earth? How am I supposed to factor that? Oh, this is going to be crazy. Nope. We look at our answers and we go, hey, we're not having to go any further than factoring out just a single greatest common factor. So when we are finding a greatest common factor, we want to look at the numbers and the variables separately. So first the numbers. We have 23, 2, and 9. Is there any number that goes into all three of those? No. No number greater than 1, I should say. Is there any number greater than 1, any integer greater than 1? Or it can be an integer that is a negative number. You can pull out a -2. That's okay. But not 1 or -1. Anything other than 1 and -1, integer, what can we pull out? No, we can't. These are all prime. 23, 2, and 9 are all prime. Their only factors are 1 in themselves. There's no factor we can bring out. So that one's done. Can we pull out a variable? Well, we've got an x cubed, x squared, and an x. Yes. So they all share at least one x. So I can do that. I can pull out an x. That leaves two x's, 23x squared, with the 23. Leaves a single x with the 2, and it takes away the single x that was with the 9. And that's it. That's all we have to do. Then we look at our answers over here to see which of those matches it. C is the only one that has an x being pulled out. So that better be my right answer. I'm going to check everything to the right of it. It sure is. I'm actually surprised at that. A lot of times they might have had 2 that had an x pulled out, and just the trinomial that was left would be slightly different to check that you had pulled out the greatest common factor correctly. But in this case, it looks like they're just testing, can you identify the greatest common factor? And so there's our answer, C. 10. Which expression is equivalent to 9x cubed plus 5x plus 7 plus 6x cubed plus 5x squared minus 5? The only real wrinkle, such as it is in these, or well, I'd say 2. There's 2 little things to watch out for. 1, this is the big one, this is the one that gets people, is right here. If this is a minus, in this question it's not, it's a plus, but if that's a minus, that's where people get tripped up. And the other is not keeping track of all of their terms. I like to write everything out and then cross them out as I combine things. Again, because this is a plus here, not a minus, we don't have to worry about changing any signs. If you get one that is a minus, like say if it was x plus 3 minus 2x plus 4, what I always do in those cases is I change this minus to a plus, and then I change everything inside the second parentheses to its opposite. So that'd be minus and minus. And then the parentheses don't matter anymore. You can get rid of them and just start combining like terms. Ta-da. That's just a little helpful piece of advice for other problems. In fact, I'm really shocked that they have this as a plus and not a minus. Because this is a plus, the parentheses do not matter. Be gone, parentheses. There you go. Don't have to worry about anything. Parentheses are irrelevant. Just combine like terms. Combine like terms, they have to be identical. For example, this 9x cubed and 6x cubed. So when I say the terms have to be identical, I mean the variables have to be identical. If this was an x cubed y on the left, if there was a y there, nope, that is not identical. It would have to be an x cubed y for both of them. Both sides would have to have that x cubed y for it to match. They have to have exactly the same variables. So here we're saying 9x cubes and 6x cubes. How many x cubes do I have? 9 plus 6 is 15. So I have 15x cubes. If you look at the answers over here, you can see that 2 of them have x cubes and 2 of them say x to the 6th. That sort of combination where it's x, you add the 2 3's together, that only happens when you are multiplying. So if this had been as a separate thing, and this is why sometimes students get it confused, if it was 9x cubed times 6x cubed, you would multiply those together to get 54, and you multiply those together, you add the exponents, x to the 6th. So sometimes students think like, I know there's a thing where you have to add the exponents. Maybe it's this. It is not this. For this one, they're just saying I have 9x cubes, 6x cubes. Altogether, I have 15x cubes. I've added those, so I mark them out. Are there any x squareds? That's my next exponent. Yes, there is. There's one over here. There is a single 5x squared, so I write it down, cross it out. Are there any x's? Yep, there's a single 5x. Write it down, cross it out. And then last but not least, I have two just constants. I have 7 and negative 5. 7 and negative 5 together are a positive 2. And now I just have to look over here on the left and see what matches it. We already said that has A as an x to the 6th, so that one's out. I don't have to go any further. So does C. And then for B is 15x cubed plus 10x squared plus 2. Nope, that is counting on someone having misread the 5x and the 5x squared and thinking they were the same, that they were like terms, but they are not. There's our answer. D, 15x cubed plus 5x squared plus 5x plus 2. Number 11. At a state fair, attendees can win tokens that are worth a different number of points depending on the shape. One attendee won S square tokens and C circle tokens. S and C would be the number of tokens that they won, worth a total of 1,120 points. The equation 80 times S plus 90 times C equals 1,120 represents this situation. How many more points is a circle token worth than a square token? So this equation, 80 times S plus 90 times C, big C, equals 1,120. This is points. S is the number of square tokens, and C is the number of circle tokens. So 80 times the number of square tokens plus 90 times the number of circle tokens equals the total number of points. So this is telling us that the S is worth 80 points and the C is worth 90 points. If you are having difficulties sometimes with these kind of problems, trying to visualize what everything represents in the equation, sometimes I think like putting real numbers in. So let's say if I had I had one S token and I had one C token. That would give me 80 times 1 plus 90 times 1, or 170. So 170 points total. Okay, so I think it's a little easier when you look at it like that. Okay, I have one S token and one C token, and together they equaled 170. Well, this over here, 80 times S gave me 80 of those points, and here 90 times C gave me 90 of those points. So the S was worth 80 points, the C was worth 90 points. And they love doing this. They love having equations with a lot of variables and going, all right, what does this mean? What does that mean? Find these. So if this is an area that you have a problem with, or a difficulty with, I should say, find these practice problems, practice them. That's one of the best ways because they're very, very common. All right, so my S token is worth 80 points. My C token is worth 90 points. And the question again, how many more points is a circle or C token worth than a square or S token? Well, it's just the difference between 80 and 90, and that is 10. So D is my answer. Let me zoom out a little bit so we can see all the lines and all the options. In the given scatter plot, a line of best fit for the data is shown. Which of the following is closest to the slope of the line of best fit shown? They love lines of best fit, but you do not have to know how to draw a line of best fit. If you are in a statistics class, that may happen. That does not happen on the SAT. So in a statistics class, they might have, all right, here's all my little data points. Can you figure out what the exact line of best fit is that best is closest representation of this data, where the distance from the data to that line is the smallest overall? I'm being very general here when I'm defining this, but that's the general idea. You do not have to do that on the SAT, so don't worry about it. The only things you'll ever be called to do on with a line of best fit on the SAT is if you'll be given all the points, you'll be given a line of best fit, and they may ask you what the slope of that line is, or they might say, according to the line of best fit, what is y going to be when x is 5? And then you're just finding out what the coordinates are, what the y value is. So this problem here is one of the former, one of those slope problems. And it says, which of the following is closest to the slope of the line of best fit? With this, the one thing I can see that you want to be careful about is that we have these big gaps down here that each represent 1. And here we have these little small gaps that each represent 1. So this same space, if I went the same here, on the X it means 1, on the Y it means 2. So don't let that suck you in and go like, okay, like, it draws you in and go like, I know it's going, it's going over 1 and up 1. No, you went up 2 according to their scale. Always be mindful of that. So we don't have to be super precise. We can just pick 2 points that it's close to, because these answers are wildly, let me move up. These answers here are wildly different. We have one a slope of 0, 1/2, 1, and 2. So if I pick a point that is not exactly on the line, but it's close, it'll be close enough. So I'm going to pick this point right here, which is not exactly on the line, but close enough. And this one, which looks exactly on the line. So here, this point is 2, 5. And this other point is 3, 7. And you can either count it out to go rise over run, how far we go up and down over how far we go left and right, or you can do the equation, which is change in y over change in x. So if we did this rise over run, just so you can be very careful that we're counting out properly. So we go up 1, 2, we go up 2, and we run to the right 1. 2 over 1, or a slope of 2. If you do the change in y over change in x equation, you start with either one of these points. It does not matter which one. I'm going to start with the one on the right, and I'm going to subtract the ones that are on the left. Y's go on top, change in y goes on top, so 7 minus 5, and on the bottom, 3 minus 2. I absolutely could have chosen to do 5 minus 3 over 2 minus 7. You will get the same answer. In this case, I'm getting a positive over a positive. If I did it the other way, I would get a negative over a negative, which would still give me a positive answer. They both give you the same positive answer in the end. It's fine. So here, 7 minus 5 on top, that's 2. 3 minus 2 on the bottom, that's 1. Again, 2 over 1, or 2, is my slope, and that is D. Number 13. A circle has a radius of 2.1 inches. Okay, so I've got a radius 2.1 inches. The area of the circle is b pi square inches, where b is a constant. What is the value of b? Well, what is our area of a circle? What's the formula for that? It is pi times the radius squared. So I take that radius here, 2.1, and I'm going to put it in here, and so I'm going to square it. 2.1 times 2.1 is 4.41. So the area of this circle is 4.41 pi inches squared. I don't have to do anything else. There's my pi inches squared, B is 4.41. And that's my answer. So just write in 4.41 as your write-in answer, and that is B. Number 14. In triangle XYZ, angle Y is a right angle. Okay, so I have XYZ, and I don't exactly know. I'm just drawing a right triangle. This is not going to be to scale. X, Y, and Z. And I go, wait, no, I did that wrong. Y is a right angle. Okay, let me back it up. X, Y, Z. Always double check at this point. Just saying. That's one of those things, like just that little example I just showed you. It's so easy to do that. And then from that point forward, everything that you're drawing here is going to be wrong, and it's just going to cause you confusion. Always, always, always double check when you first start out that you're drawing everything correctly. All right, so now we have X, Y, Z, and angle Y is the right angle. Like, okay, I've got that. Point P lies on X, Z. Okay, so point P is on X, Z. And point Q lies on YZ such that PQ is parallel to XY. So it's a line, it's going to be parallel to this one. It's going to be going down. And this point down here is point Q. Okay. If the measure of angle XZY, there's that angle right there. If that angle is 63 degrees, what is the measure in degrees of angle XPQ? Okay, so this is my one where I don't know what that is. Right, the fact that these are two parallel lines is a big part of this. When we have parallel lines, there's parallel lines like this, and it's being cut by two different transversals actually. This is a transversal and that is a transversal, and they're both cutting these parallel lines. When we have parallel lines that are cutting a transversal, we end up with angles that are congruent and angles that are supplementary. So in this one right here, this angle is congruent to that angle, and it's also congruent to that angle, and it's congruent to that angle. They are matching intersections. Then our other one, let's do it with purple. This angle is congruent to that angle, is congruent to that angle, is congruent to that angle. If you're in geometry class, you have to know the names for the theorems that compare all of these, like inside, same side, interior angles, same side, exterior angles, corresponding angles, all these sort of things. You do not have to know those names for the SAT. All you have to know is this right here. That's it. You just have to know which angles are going to correspond, are going to be the same. In this case, all the purples are the same, all the greens are the same, and purple and green are not complementary, supplementary. They add up to 180. They make lines, straight lines. So in this case, our little parallel lines that we have here, this angle right here, actually I'm going to use a different color. Let's use blue. Let's use baby blue. This angle right here is the same as this angle right here. Now that doesn't help us with this one, but if I could figure out what this angle QPZ is, then I could say, oh, well, my angle in question, the one I need to know, is supplementary to it. Well, how can I figure it out? Well, I've got this triangle here, and I know that this is a right angle. How do I know it's a right angle? Because this is a transversal too. It's a transversal of these two parallel lines. So it has corresponding angles. So just like up here, we had this angle and this angle are corresponding, so they're the same. Now this angle and this angle are corresponding. They're the same. So it's 90-degree angle, and I know this other angle is 63. And in this purple triangle that I have, those add up to 180. So 90 plus 63 plus angle QPZ, those all equal 180. Then I can solve to find out what angle QPZ is. When I subtract 90 and 163 from 180, 90 and 163 together is 153, and I subtract that 153 from both sides, I am left with angle QPZ. And now I know that QPZ, the measure of angle QPZ, is 27. Okay, so now I know right here, this is 27. And these two angles make a line together. I'm making this so messy. But now I know that they together, they are equal to 180 minus 27, which, look down there and see what that is. Spoiler alert, it is 153. You also could have, if you know that particular geometry, I think it's a theorem. It's a theorem, postulate. I tend to get those mixed up. Theorem that if you have a triangle that's it's like this and it goes off, you have a line going off extending one of those, then this angle right here is always equal to the sum of the two angles that are not touching it. It's touching this one right here, but it's always going to be equal to the sum of these two. So that is the theorem. If you remembered that, you could have just jumped to that and said like, oh, well, I'll just add those two together and then I'll get that third angle. But you can absolutely also do it this other way too, like we just said, where you realize that the measure of QPZ is 27. And I made it so messy, and I apologize for that. See if we can clean it up just a little bit so I can write that and show that. I feel bad. I really do here for making it so messy. Okay, maybe this makes it a little cleaner here. So this right here is 27 because this was a right angle and this was 63. And then these two angles together are 180. They're a straight line. So 180 minus that 27 gets me that angle, and 180 minus 27 is 153. So angle XPQ is 153 degrees. And I really hope my little rambling detours did not completely derail that. And if they did, I am so sorry. But 153 is my answer. Number 15. An investment account was opened with an initial value of $890. The value of the account doubled every 10 years. Which equation represents the value of the account, M of t in dollars, t years after the account was opened? The fact that it's doubling every 10 years, this is growing exponentially. So like if you started with $1, then it would be $2, $4, $8, $16. And if you graph that, you're going to get a curve that's going upward. If it is simple interest, it's linear. The difference is simple interest, you're only earning interest on your initial investment, and that's it. You earn interest on that. Then later you earn more interest on that. You earn more interest on that, and you're just adding them each time. What happens with, it's not letting me erase, there we go. I'm just drawing all over. What happens with compound interest is that you earn the interest on this, and then you earn the interest on all of this. Then you earn the interest on all of this, like that interest. You're earning interest on interest, and that's why people love it so much. Usually for the SAT, I've seen a couple where you need to have the formula for compound interest memorized. It's not really applicable for this problem, but I'm going to show it to you because you may need it for other problems. The formula for compound interest is P times 1 plus R over N to the power of N times T. P here is your principal or your starting amount. R is your rate, the percent of increase. T is the time period. Usually it's years. It doesn't have to be, it's usually years. And N, which occurs in these two spots, is how many times you're compounding the interest in that time period. So let's say this was for a year compounded daily, then your time would be 1 year, but there's 365 days in a year, so you'd put 365. That's what it says for how many times compounded in the time period. This is a good equation to know. If nothing else, just knowing that the principal is out front and you get multiplied by something in the middle that represents the rate of increase, and the time is going to be on the exponent. Just that general knowledge will help you out in the SAT, even if you don't have this exact formula memorized. Also look at the one for population growth. That's my homework for you. Look at the equation for population growth, because that shows up a lot and they do not tell you what the population growth formula is. All that being said, I know I'm taking a little time to get to the problem, but I'm just letting you know for your study, that's important to know. For this particular one, while they are asking you to craft the equation of it, you don't necessarily have to know how the equation works to be able to solve this problem. They're telling you the initial amount was $890, and they're telling you that in 10 years, it doubled. Now, it's saying T is representing the number of years. So if it doubled, it means that whatever equation is correct, it will, if I plug 10 in for T, I will get 890 times 2 because it doubled in 10 years. So we don't really have to know what part of this equation is which. We don't have to know which is which. We don't have to know which is the rate, which is the compounding, what's the principal. We don't have to know that. We just have to know which of these equations, if I plug 10 in, am I going to get, and I do the math, am I going to get the same thing as if I just do this math, 890 times 2. And 890 times 2 is 1780. Let me just double check that math in my head. Yes, 1780. 1,780. So just 890 times 2. So there's a couple ways you could look at this. You could look at all these and you could plug 10 in and you could do all this math for each one and see which one gives you 1,780. Or you could recognize, this is quicker, that each one is 890 times something. So then you go, okay, it's 890 times something. So is this. This is 890 times 2. So since over here I've got 890 times something over and over and over again, how about I just look at this part and see which of these 4 things, if I plug 10 in for t, am I going to get 2? And that's a lot less math, and we don't even really need our calculator, frankly. Let's look at the first one. We have t over 10 up here. It's not letting me undo. There we go. T over 10. So if I put 10 in there, I get 10 over 10, or 1. So I'd have 1/2 to the power of 1. That's just 1/2. That's not 2. That one's out. Next one. I think you can see where this is going. We got 1/10 to the power of t over 2, or 10 over 2. 1/10 to the power of 10 divided by 2, or 5. 1/10 times itself 5 times. Is that going to get me to 2? Nope. That's just going to get smaller and smaller. It's going to be like a 10th, a 100th, a 1,000th. It's going to get smaller and smaller. Nope, that's out. Ooh, how about this one? 2 to the power of t over 10. 10 over 10 is 1. 2 to the power of 1 is just 2. There you go. That's it. That's your answer. You want to double check? Our last one there would be 10 to the power of t over 2, 10 over 2, or 5. 10 to the power of 5 is not 2. 10 to the power of 5 is like 2, 3, 4, 5 is 100,000. So no, that is not correct either. That's a double check. And then if you really want to double check, you could just put all that into your calculator and you will get 1,780. So a lot of times with these kind of problems, look at your answers and you can get to the answer much quicker than doing things in a more lengthy way. But I don't apologize for showing you that compound interest formula because I've seen enough times where it shows up on the SAT that I think it's a useful thing to know. Number 16, y is less than x and x is less than 22. For which of the following tables are all the values of x and their corresponding values of y solutions to the given... I misread that. For which of the following tables are all the values of x and their corresponding values of y solutions to the given system of inequalities? There we go. That's better. Now, if you wanted to graph this, there's no one saying you can't graph it. You're going to get 2 dashed lines that intersect. Whenever you have a system of inequalities, I am not drawing the answer. I'm just drawing a system of inequalities where they're both less than or greater than. You're going to get 2 dashed lines, and then you're going to get areas of shading. It might be that area is shaded. It might be that area is shaded. It might be this area is shaded. And you're going to get you're going to get the overlapping. And where they overlap, where those shades overlap, that would be the area where all the solutions to the system of inequalities are found. Now, if this was a more complicated setup, if this was like, y is less than x squared plus 5x minus 10, and also y is less than or equal to, 5x minus 13, then yeah, I would say you could put that in your calculator and see where the shaded parts overlap and look for which of these fits it. But as it is, I would not recommend that. Don't waste your time putting it in a graphing calculator. I would just look at my answers and see which of them fits this bill. And I'm going to zoom in a little bit. I'm going to cut it off, but I'm going to rewrite. It was y is less than x and x is less than 22. So just start with the first one. Y is less than x. And very quickly scan and see which of these are not fulfilling that. All right, the first one here is y less than x for each one. Yeah, 18, 19, 20, that's less than 19, 20, 21. Each pair is less. All right, next one, right off the bat, 19, 20. Is y less than x? Nope. That one's out. I don't know if this purple is showing up. Let's change this to a darker. There we go. That one's out. All right, C. Here is y less than x, 22, 23, 23, 24, 24, 25. Yes. Okay, that one's still in the running. And D, 24, 23. Oh, don't have to go any further. 24 is not less than 23. That one's out. Then we take our next part. X is less than 22. And just very quickly glance at these and going, okay, yeah, in that one, X is less than 22. That looks like my answer. But C, just double check. Nope. X is not less than 22 there for all those instances. A is my answer. And personally, I think you can scan those numbers and do that pretty quickly, much quicker than putting it into a graphing calculator and then trying to find all of these points where they overlap. My only sort of caution would be just be careful. Don't make a careless error. Don't misread this as y is greater than x and get the wrong one, because I guarantee you, they have every combination represented in those four. That's, what they want to trip you up. So just be careful, and you can get this one right and go on your way. It is A. Number 17, which expression is equivalent to h to the 15th times q to the 7th all over h to the 5th times q to the 21st, where h is greater than 0 and q is greater than 0. They're just telling you this to let you know that there are no impossible solutions to this. Because if either of those was 0, then there would be a time where the denominator here is 0, and we can't have that. We would have an unknown, impossible answer. No solution. So they're just saying it has solutions. It's all good. You don't have to worry about the zeros. What do? If you have, I'm going to show you why this works. If you have exponents and you are dividing exponents, you can subtract the exponents and get your solution. So if I had, let's say, x to the power of 3 divided by x to the power of 2, that is the same as x to the power of 3 minus 2, or x to the power of 1, just x. The reason this works is because x to the power of 3 is the same as x times x times x. X to the power of 2 is the same as x times x. And when we have things multiplying on top and bottom, we can cancel out matching things that are being multiplied, not added or subtracted, multiplied. So here I have an x and an x, cross them out, x and an x, cross them out, and just one's left. And if you really want to know why you can do that, is because you can split them all up. You can say that's, you can split them up like this. So you can say it's x over x times x over x times x over 1. X over x is just 1. X over x is just 1. 1 times x over 1. There's your exponent rule and explanation for the day. So the application that we can use in this problem is because we have this h to the 15 times q to the 7th over h to the 5th times q to the 21st. We can treat them separately because they're being multiplied. We can say what cancels out of this group and what cancels out of that group. And we can do that. Now keep in mind, like I said, you subtract. Hang on to that thought for just a second. So on this first one, you have h to the 15th over h to the 5th. So I bet you're asking, why did you take the time to show us that about the equations and the canceling out? Aha! Will become clear very soon. So here we have h to the 15th divided by h to the 5th, so we can subtract. 15 minus 5 is h to the 10th. There we go. But here, hey, 7 minus 21. Wait, that's negative. Can you have a negative exponent? You'd have a negative exponent on top, right? 7 minus 21, that'd be q to the power of negative 14. I don't see anything like that over here. I don't recall seeing negative exponents in fractions. You're not going to. That comes into our second sort of exponent rule that applies here. When you have a negative exponent, so like q to the power of negative 14 is the same as 1 over q to the power of 14. So it would just move it down here. So instead of saying h to the 10th times q to the negative 14th, it would be h to the 10th times q over divided by q to the 14th. Now that is using all your exponent rules, but personally I think it's easier to think of things canceling out. And that's why I showed you that it's things canceling out, because imagine it this way. I've got 15 h's, and yeah, I'm going to write them all because that's what I'm doing today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Am I reconsidering my life choices right now? Yes, I am. All right, and then I'm going to multiply this by, my next problem is showing up in the outright corner. Let's scoot that over a little bit. And I'm multiplying this by q to the 7th. 1, 2, 3, 4, 5, 6, 7. Am I dreading the q to the 21 that I'm about to do? Oh, you better believe I am. On the bottom, I have h to the 5th. I have 1, 2, 3, 4, 5 times 21 q's. Oh, help me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. The letter Q has lost all meaning. So now, when I think about canceling, you can see why it ends up with 10 H's left on top and 14 Q's left on the bottom. Because if we are canceling, we can cancel. And then cancel that one, cancel that one, cancel that one. All right, I've canceled all the H's I can. Now for the Q's. Cancel. One on top, one on bottom, 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 one on top, one on bottom. And there we go. And now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 H's left on the top, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 Q's left on the bottom. So while your teacher may explain it to you as these are exponent rules, and why, and you have a negative exponent, and then it moves to the bottom, all that's very true. But if you think of it more as things canceling out, like I just spent way too much time completely illustrating, then you go here and you look like, okay, if 5, these 5 are going to disappear because there's more on top. 5 go away from this, 10 are going to be left. Okay, with these 7 on top are going to disappear. 7 of these 21 on the bottom are also going to disappear, leaving 14 on the bottom. I think that perspective, honestly, it's a lot easier and a lot faster for this particular type of problem. And that gives you your answer, which is A, h to the 10th, q to the 14th. But yeah, if you want to look at it as exponent rules and subtracting and the negatives go on the bottom and stuff like that, I'm not going to stop you. Go for it. Whatever makes the most sense to you is what you should use. Number 18, 3y equals 4x plus 17 and negative 3y equals 9x minus 23. The solution to the given system of equations is x and y. What is the value of 39x? Notice they are not asking you what y is. We don't need to know what y is. It doesn't matter. The only thing that's important with that first sentence there is that they're telling us there is a solution. It doesn't matter that the solution is saying to the given system of equations is x and y. Like, do I need to know that? Do I need to know what y is? No, you don't. You just need to know there is a solution. Because in linear equations, there's only 3 options. You can have 2 lines that cross. You can have 2 lines that are parallel. Or you can have 2 lines that are identical. So when they cross, we have a single solution. When they are parallel, we have no solutions. And when they are on top of each other, we have infinite solutions. So the fact that there is a single solution tells us the lines cross. There's one solution. Okay, good. Now you can put this into your calculator. You type all this in and you'd see where they cross. That would give you the coordinates of x and y. And then you can take that x value, multiply it by 39 and get your answer. Nothing wrong with that. My preferred method, and when I look at it, this would be faster for me. I look at these two and I go, okay, so a system of equations, you can solve it by graphing, substitution, elimination. Those are your 3 methods here. Right off the bat, these two, that 3y and negative 3y, they are going to cancel out. So I'm going to do elimination. And I also am doing this because they're not asking for x. They're asking for 39x. And any time that they ask for a weird variation, like, here's the solution, x and y. What is 6x plus 2 equal to? What is 7x minus 15 equal to? It always gets me thinking, and 9 times out of 10 this is the case, that if I do something like substitution or elimination with these equations, I'm going to get an answer, or like somewhere along the way, I will get something that's close enough to 39x that I can kind of jump ahead a few steps. We'll see if that happens here. All right, I am going to add these together. So that is how we eliminate. These are going to cancel out. So when we add them together, 3y and negative 3y is 0. There we go. 4x and 9x is 13x. And 17 and negative 23 is negative 6. All right. And here I see, I'm like, wait a minute. I see what's happening. Because if I solve this, spoiler alert, I'm going to get a fraction for x. And I'm not a huge fan of fractions. I don't know about you. Most people are not a huge fan of fractions. So if I can avoid the fractions and having to deal with that and converting, I'm all for it. And here's what I see. What stands out to me is this 13x. 39x is 13x times 3. So if I quickly solve for 13x by adding 6 to both sides, I get that 13x is equal to 6. So now to find out what 39x is, I don't have to solve for x and then multiply by 39. So I would get 6/13 and then have to multiply by 39. I don't have to do that. I can just go, hey, I want this to be 39x equals something. So if I multiply both sides by 3, ooh, missed that, missed my parentheses there, then I will get 6 times 3 or 18 is equal to 13x times 3 or 39x. So for me, I'm good at elimination. I know that about myself, that's a skill that I can do that quickly. For me, this will be faster than graphing it. If graphing is faster for you, by all means, graph it. The one sort of thing that you're going to recognize there, though, is, because x is 6/13, if we had solved for x in this stage right here, we would have got x is 6/13. When you go to look at the graph of, where they intersect, whatever those lines look like, you're going to get this decimal for x. 6/13 is going to be an ongoing decimal. It's not going to stop. And so you're going to get a number here that will be a decimal. And when you multiply it by 39, you're not going to get one of these exactly. It'll be close, but it won't be that exactly if you use a rounded, decimal for this xy. And that may cause a moment of confusion to go like, wait, did I get it wrong? No, it's just because you're rounding, that sort of thing. When you do it this way, you find out precisely that it is 18. So that's my only sort of cautionary statement on this one, is when you do it by graphing, you're going to get a fraction, or you're not going to get this fraction of 6/13. You're going to get a decimal presented to you. On most calculators, they will present it as a decimal. And then when you multiply by 39, you're not going to get exactly one of these. Don't let that, confuse you or get you away from the wrong answer. Going like, did I do something wrong? No, you didn't. D18 is your answer. And they're trying to push. How do I say that? Push? I don't know why I said it that way. They're trying to push you to do elimination because you reach this little halfway point where it can very quickly become 39x and you don't have those decimals involved. Yeah, that's how they're trying to catch you on this, trying to force you to do elimination. But it's ultimately your decision. And so you get D as your answer. Number 19, h of t equals negative 16t squared plus b. The function h estimates an object's height in feet above the ground t seconds after the object is dropped. All right, so it's not thrown in the air, it's just dropped. So someone is standing on this little ledge and it's going boom, like that. And it's going down, it's going to hit the ground. All right, and it's represented by negative 16t squared plus b equals h of t, where t is the time in seconds, b is a constant that we don't know what it means yet, what it is, and then h of t, this is going to be the height of the object as it's falling. Okay. This function estimates that the object is 3,364 feet above the ground when it is dropped at t equals 0. Okay, so if I'm viewing this as like my little XY graph here, superimposing it over my crude drawing of a cliff and something falling off of the cliff, Here, when t is 0, because this is going to be that axis, t, and this here is my h of t, it is 3,364 feet above the ground. So this point right here, when t is 0, h of t is 3,364 feet. Okay, so, and that little dot there is just a stray dot. That's not a decimal. So that tells me this right here is representing, if you have negative 16 t squared. T squared is just a parabola. Negative flips it upside down, makes the parabola go upside down. 16 makes it much narrower. This is one of those traits, if you learn these basic traits about parabolas and just functions in general, it can help you out a lot. And if you have a number, a constant that's being added on the outside or subtracted on the outside, that moves it up or down on the y-axis. If you had a number, a constant inside here, by which I mean like if it was negative 16 times t minus 2 squared, if it was like that, this number on the inside moves it left or right, but the opposite. So if it's minus 2, it moves it towards the positive 2 spots. That kind of thing can be very helpful. It shows up a lot. So I know this is a negative 16, okay, because I drew half of, an upside down, narrow little parabola. That's my negative 16t squared. This b, I know, is the number that moves the function up or down. So here it moved up 3,364. So now I know my b is 3,364. And if you didn't know that fact about how functions move based on these numbers, you could have put in a 0 for t plus b, and you know it equals the height, h of t is 3,364. And then you just solve that. And if you do get this, this is going to 0 out. It's going to be 0 plus b equals 3,364. So b is 3,364. Either way, it gets you to the fact that b is 3,364. All right, back to our description again. Approximately how many seconds after being dropped does the function estimate that the object will hit the ground? Well, what do we know about the height of the object when it hits the ground? Well, when it's dropped, it's 3,364 feet above the ground. When it hits the ground, it is at 0 feet above the ground. So now I've got my b, and I know the height, and I know that height, h of t, height is 0. And they're wanting to know how many seconds after being dropped. So now I just need to solve for t. You can do this by looking at the graph of this and seeing where it crosses the x-axis. Now they aren't doing any, they don't have any negatives there, but we just want to be careful that we are looking at the positive number. I don't think they're trying to deceive you with any of those, but they like doing that, so just be mindful. We're looking on for this side because this, this parabola would be continuing that way as well in a graph. If you wanted to do this mathematically, you can do that quite easily as well. You don't have to factor or anything if you don't want to. So you can just start here. There it goes. It wasn't letting me draw there for a second. I can subtract 3,364 from both sides. And on the left-hand side, I'm going to get negative 16t squared equals negative 3,364. Now I'm going to divide both sides by negative 16, since that is negative 16 times t squared. I'm wanting to undo that to get t squared by its little lonesome. And when I do that, then on the left side, I am going to get that t squared is equal to, I forgot my little, I didn't put a negative 16, I put negative 6. Sorry about that. When I do this, when I divide both sides by negative 16, I get that t squared is equal to 210.25. Now to undo this squaring, I just need to square root both sides, and I get that t is equal to 14.25 14.5. Normally I would say plus or minus, but seconds can only be positive in this case. It's how many seconds afterwards, so only the positive is the only one we need to worry about. And there is my answer, B, 14.5. Again, for this one, it's just registering, what all these numbers and constants that you're given, what they represent in here. As is quite obvious, I think, to anyone who's watched my channel, I always like drawing little sketches and stuff to help me visualize things. Just do whatever, you prefer, but definitely solve for B, and then you can find out what it is when the height is equal to 0, and that will be your T. Number 20. 2x squared minus 8x minus 7 equals 0. One solution to the given equation can be written as 8 minus the square root of x over 4, where k is a constant. What is the value of k? This is forcing you to use the quadratic formula, which is that x is equal to negative b plus or minus, that negative there in front of that b looks wonky, move it up, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this right here is sort of the big, it's 8 minus square root of k over 4. You see the similarity. We have a constant plus or minus a square root over a number. That should be a big red flag right there, a little waving, use a quadratic formula. That's what they want you to do. So let's plug these numbers in. The a, b, and c in the quadratic formula come from, if we have a quadratic that is set equal to 0, a is the coefficient or term, the integer, fraction, whatever it may be, that's next to the x squared, the constant. B is the constant that is next to x, if there is an x. And c is the constant that is by itself, if there is a constant by itself. Not always, but usually when we're talking quadratic formula, you will have ax squared and a bx and a c. Just because the ones without the bx and the c, there's other ways you can solve them. So, all right, so we have 2x squared minus 8x minus 7. So 2 is my a, negative 8, make sure that negative comes with me, is my b, and negative 7 is my c. So this negative right here in front of the b means the opposite of b. So my b in this case is negative 8, so the opposite of that would be positive 8, plus or minus the square root of b squared minus 4ac, so negative 8, there's my b squared, minus 4 times my a is 2, and my c is negative 7, and that's going to be all over 2a, or 2 times 2, which is 4. Okay, so the 8 and the 4 are already there, so I know I'm not going to have to simplify anything with this square root. If this was something else, if this ended up being 4 and 2, something like that, or it was just, 2 minus square root, then my mind is immediately thinking, okay, whatever shows up under this square root, I'm going to have to simplify it. I'm going to have to pull something out and then, find a greatest common factor. That happens a lot with the quadratic formula. But here, because the 8 and the 4 are in the answer they're given, and I have the 8 and 4 there, don't have to worry about that. I can just do what's the math that's under the square root, and I know I've got my correct answer for the value of k, which is nice. So let's do that math. Negative 8 squared is 64. 4 times 2 is 8. 8 times negative 7 is negative 56. So it's 64 minus a negative 56. So that's the same as plus a positive. And when we add those together, we get 120. So when I said earlier that I don't have to simplify this, does that mean I couldn't simplify the square root of 120? That is not what it means. You can simplify the square root of 120. You could make this a more simple answer, but you do not have to, because that's not what they're asking for. And if you did, you would get it wrong because they're saying that it can be written as 8 minus the square root of a number over 4. So if you simplify this and simplify it down and go, that's what's left on the square root, you're going to get it wrong and you'll have done extra work. So that's a double whammy. Always make sure we read it carefully. They don't want us to simplify it. They just want to know that when there's an 8 and a 4, what number is under The square root, that's 120, so 120 is my answer. Number 21. A line intersects two parallel lines forming 4 acute angles and 4 obtuse angles. You know me, I'm immediately going to draw this. Okay, so a line intersects two parallel lines forming 4 acute and 4 obtuse. All they're telling me is it's not perpendicular to it. That's it. Every other combination that's not perpendicular, if you have two lines, two parallel lines, and a transversal, you're going to have 4 acute and 4 obtuse. The acute ones, I'm going to put here in red. They are all matching. And the obtuse ones, I'm going to put in blue. And all the blue ones match. And the pink and blue angles are supplementary to each other. They add up to 180 degrees. A single pink plus a single blue will be 180 degrees. This is true of all parallel lines and transversals. The measure of one of the acute angles is 9x minus 560. Okay, so these little acute angles, of which there are 4, and they're all the same, they're 9x minus 560. The sum of the measures of one of the acute angles and 3 of the obtuse angles is negative 18x plus w. What is the value of w? Okay, I don't have a representation for the obtuse angle. What I do know is that the obtuse and the acute angle, the pink and the blue here, add up to 180. So if I say, the acute plus the obtuse equals 180, and the acute is 9x minus 560, plus the obtuse equals 180, then I can subtract that from both sides. Minus 9x minus 560. And now I know that that obtuse angle is equal to 180 minus 9x minus 560. Now I want to tidy that up a little bit. Since I have this minus the whole thing, I'm going to change this to a plus and change everything on the inside to the opposite. And now I can get rid of those parentheses. And I can just combine like terms. So I have that negative 9x, and then I have 180 plus 560, which is 740. Okay, so now I know that the obtuse angle is equal to negative 9x plus 740. Okay, the sum of the measures of one of the acute angles, so 9x minus 560, the sum of the measure of one of the acute angles, and 3 of the obtuse angles, negative 9x plus 740, is going to be equal to, I'm going to write it up here, not down there, negative 18x plus w. So let's do all this math and simplify it. Combine like terms, that's what I'm talking about when I say do the math. Let's simplify by combining like terms. All right, so first here I'm going to distribute. 3 times negative 9x is negative 27x. And then 3 times 740 is 2,220. Let me double check that. Yes, it is. Okay. And then I have my 9x minus 560. So now I'm going to combine like terms. And when I do that, 9x and negative 27x together, I add those together, I get negative 18x. Hey, looking very close to where they want me to go. And then when I combine negative 560 and 2,220, I get 1,660. And there we go. This all combined is equal to negative 18x plus 1,660. So the question is, what is the value of w? W is going to be 1,660, and that is my answer. Number 22. For the linear function f, the table shows 3 values of x and their corresponding values of f of x. If h of x equals f of x minus 13, which equation defines h? So anytime we have a function, we have an input and an output. X is our input, f of x or h of x, whatever it is, of x is our output. So it's saying we plug a number in, like let's say if it was 3x minus 2 equals f of x. The numbers you plug them in for x, you do this math, the number you get is your output, f of x. So that's what is represented in this chart. We have these x's and we have f of x. Now this particular problem that we have here, we are given two functions. We have f of x and we have h of x. So for f of x, that's this table. H of x is this minus 13. Now there's two ways we can go about it. We can either figure out what the equation of f of x would be, and then plug it in here, subtract 13, combine any like terms if there are, and see which of these we get. We also can change this table to represent h of x. So I'm going to show you both ways. All right, to figure out what f of x is, this is a linear function. It's a line, so it will be able to be put in the formula, the equation y equals mx plus b, where m is our slope and b is our y-intercept. So slope is rise over run, or change in y over change in x. So, all right, so I have 2 points. I'm going to just pick these first two. The change in y, so -4 is 0, and -19 fifths and 1, and -19 fifths. I'm going to change that into a fraction form just for my own purposes. That's -3 and 4 fifths. I think it makes the next step just a little easier for my mind. Another thing you could do is you could have changed this into fifths. It's another way you can do that. Or you can just put it in your calculator, whatever you like. So change in y, I'm going to start with this one and then go to this one. It doesn't matter which one I start with. So I'm going to have 0, that y, minus this y of 1. And then on the bottom, change in x, -4 minus -3 and 4 fifths. So minus a negative is the same as plus a positive. So on top, 0 minus 1 is -1. And on the bottom, -4 plus a positive 3 and 4 fifths would just leave a single -1/5. So -1 divided by -1/5. Those negatives cancel out. So those are gone. 1 divided by 1/5. How many 1/5ths are there in 1? 5. So my slope is 5. All right, so now I know in my original equation up here that my slope is 5. Now I need to know what my b is, so I plug in any of these points over here on the left. I'm going to use that top one again, so that my f of x, or y and f of x here are interchangeable for the purposes of this problem. So that y, or f of x, is 0. Then I have 5 times my x, which is -4. And we still have that b. I'm just plugging in the y, or f of x, the x, and I'm going to solve for that b. So 0 equals 5 times -4, -20, plus b. Then to solve for b, I add 20 to both sides. And we get that b is equal to 20. So my final equation is going to be y, or f of x, equals 5x plus 20. There we go. So yeah, because I'm using these back and forth, because if you look in your book, it's going to say y equals mx plus b. Y and f of x are going to be essentially equivalent for this problem. So f of x equals 5x plus 20. Now I know that h of x is equal to f of x minus 13. Now I know that f of x is this. I can plug it in right there. And that would be 5x plus 20 minus 13. There's not anything weird going on the outside of this 5x plus 20. There's not a negative on the outside of it. There's not like a negative up here. There's not a number in front that needs to be distributed. So I can just get rid of these parentheses. So 5x plus 20 minus 13, I can combine these like terms, and I get that h of x is equal to 5x, 20 minus 13 is 7. H of x equals 5x plus 7. All right. You also could even say, honestly, at this point right here, since it's minus 13, if you understand, or if you've studied, which I highly recommend you do, I have videos on this kind of thing about transforming functions. If you understood that minus 13 would bring it down 13, you go, oh, here the y-intercept is 20. If it goes down 13, the y-intercept would be 7, so it's 5x plus 7. If that didn't ring any bells, then I highly recommend looking into or doing a little bit about translating functions, because it's not needed for this particular problem necessarily. You can use it, but it's not absolutely necessary. However, there are problems on the SAT where it is necessary. So just a little SAT public service announcement. Okay, so what if we did it the other way I said, which is where we change the table? Well, for that, we want to say x and h of x. And I know that my x values are -4, -19 fifths, and -18 fifths. And it says that h of x is equal to f of x minus 13. So I just need to take all these values and subtract 13 from each one. 0 minus 13 is -13, 1 minus 13 is -12, and 2 minus 13 is -11. Now I do the same exact thing that I did before to find the equation for this function. I need to find the slope, then I need to find the y-intercept. Slope is change in y over change in x. I'm going to use those top two again, and this time I'm going to start with this and go this way, by which I mean I have my two ordered pairs, -4, -13, and -3 4 fifths. I'm changing it again, and -12. And instead of saying, you know, this minus those, I'm going to do this minus these. This one minus these, because it does not matter. It's the same. So -12 minus a -13, there's my y's on the top, and -3 4 fifths minus a -4. 12 minus a negative or plus a positive 13 gives me a positive 1 on the top. -3 4 fifths plus a positive, the same as minus a -4, gives me a positive 1/5 on the bottom. Here we are again, same sort of thing. 1 divided by 1/5. 1/5 goes into 1 5 times. So now we're at a very similar place that we were before, but instead of f of x, this time it's h of x equals 5x plus b. And to solve for b, I can pick any point. I'm going to pick this first one here again. I get that h of x equals 5x plus b. I know that my x is -4, and my h of x is -13. So -13 equals 5 times -4 is -20 plus b. To solve for this, I add 20 to both sides. -13 plus 20 is 7. 7 is my b. And all right, now I can plug that in. 5x plus 7. This isn't a thing that I can think of as I don't think you can use a graphing calculator to easily solve this. I think this is definitely one you're going to have to use some of these techniques. But yeah, there's multiple ways you can do it. All are valid. Just do whatever makes the most sense to you. Number 23. The linear function g is defined by g of x equals b minus 15x, where b is a constant. If g times c plus 7 equals c over 4, where c is a constant, which of the following expressions represents the value of b? Okay. What they want you to do, let's write this out here. G of x equals b minus 15x. They tell us it's a linear function, and this is very similar to a y equals mx plus b kind of format. They're just reversed. But it doesn't really matter. It's the same thing. you know, this would be your slope right here. This is going to be your y-intercept. They've just reversed it. But that doesn't really play a huge part in what we're about to do. Just letting you know that that's what's going on. They're telling us g of c plus 7 equals c over 4. So then they're saying, okay, so what is b? Okay. Like, if you this made you go a little, what? I understand. It's not likely that you've seen a problem exactly like this in your math book, but we have to use what we've learned in math class to figure this out. So g of c plus 7, it's saying when I plug c plus 7 in as my x value, so everywhere over here there's an x, I'm going to plug in c plus 7. And then when I do that, when I plug in c plus 7 and I do this math, I'm going to get c over 4. All right, so let's see what happens here. All right, I'm going to do that. I'm going to plug in c plus 7 wherever there's an x. Okay, so b minus 15 times x. So I'm going to replace that x with c plus 7. And I know once I do this math, I'm going to get c over 4. All right, let's start distributing here. Let's get rid of this a little bit. I'm going to change this to plus a negative. Just make it a little more straightforward. So I still have that b. The b stands alone. Negative 15 times c is negative 15c. And negative 15 times 7 is negative 105. This equals c over 4. I want to get rid of that 4, c over 4. So I'm going to multiply both sides. I'm going to multiply everything by 4. Multiply all this by 4, and multiply this by 4. So on the left, I'm going to get 4 times b, or 4b, plus 4 times negative 15c is negative 60c, and 4 times negative 105 is negative 420. And this is equal to c. Okay, so now I just need to solve for b, because that's what, you know, that's the goal. When it says, which of the following expressions represents the value of b? Something I didn't point out, and I probably should have, is if you look over here at the answers, all of these have c in the answer. So we're not going to get a plain numeric value for b. This is one of those very complicated way of saying it, and it's just now becoming clear when you're looking at it. It's a very complicated way of saying, put b in terms of c. It's one of those, you know, like c is over a is equal to b. Put c in terms of a and b. And you're supposed to multiply both sides by a, and you get c equals... That's what we're doing here. It's that kind of problem. They've just dressed it up with all this other stuff. So let's get b by itself. So I'm going to move everything that's not b over to the other side, and then I'm going to, solve for b. So first I'm going to add 60c to both sides, and I get 4b plus a negative 420 is equal to c plus 60c is 61c. Then I'm going to, I'll zoom out because I'm running out of room, and I see that this the next problem is getting in the way here. Give me some more space here. Then I'm going to add 420 to both sides. So now I have 4b is equal to 61c plus 420. And I'm going to write this up here so I can kind of keep it about the same size. 4b equals 61c plus 420. Okay. Then to get rid of that 4 in front of the b's, it's 4 times b. I need to undo that. So I need to divide everything by 4. Now just a b is on the left. That's what I want. I want something now. Just b. What is b equal to? 61c over 4. I can't simplify that. Just stays 61c over 4. And 420 divided by 4 is 105. Now, a little sort of caveat is if you're saying, wait a minute, 105, I remember there's 105 up here. Could I have I have the b right here. Could I have done this without, at this point, we got the c over 4. Could I have done this, got the, moved all this over to the other side and done it without multiplying by 4? Absolutely. Absolutely could have. I'm just showing you, to my mind, I don't like fractions. I like to get rid of the fractions. So it made it easier for me when I was working it. If you want to back up and, if you're looking for, wait, didn't we just find the answer? We did. It's C, 61C over 4 plus 105. But I'm going to back it up and just show you. See if we go back to just this point. Okay. You could even move this whole thing over here first if you wanted to. Absolutely. Because it's plus a negative 15 times C plus 7. So you could do plus a positive 15 times C plus 7. And you could do that on both sides. And then you would have B equals C over 4 plus 15 times C plus 7. But as you see, that is not represented up here, so you would have to keep going. So, same as before, we'd have to, there it goes, let me undo. Distribute 15 times C is 15C, and 15 times 7 is 105. So I have B is equal to C over 4 plus 15C plus 105. So it's at that point, you have to be very careful, because we have some other numbers over here, some other answers over here that I think are a little distracting, because you might go, hey, 15C plus 105, that's awfully close. That must be the answer. No, that's not the answer. You don't want to get distracted by that 19C over 4 and go, 15 and 4. No. You have to convert this into fourths. So that would be 15. If you convert that to fourths, it's 15 over 1 times 4 over 4, and you get 60 over 4. So it would be C over 4 plus 60C over 4. You add those together, 1C over 4 plus 60C's over 4 equals 61C's over 4, and that 105 just stays as it is. So yeah, that also gets you to that same answer, C. It really is just about comfort here and what makes the most sense to you. There's more than one way. As long as when you're doing these sort of problems where it's solved for a variable, there's usually more than one way you can get to the end. The key is just to keep both sides balanced by doing the same thing to both sides, and you won't mess up. You might go down a wrong alley, and you might get to a location where you're like, wait a minute, I'm getting more complex and not simpler. That does happen. But you're not going to go to a place of no return, if you know what I'm saying. So yeah, any of these ways will work. You will get to the answer C, 61C over 4 plus 105. Number 24. In triangle XYZ, angle Z is a right angle. Okay, so I immediately go, all right, got a right angle, Z is the right angle, XYZ. I know I haven't drawn it to scale, but I just want a visual reference, something I can start writing on. The length of YZ is 24 units, okay? If the tangent of X equals 12 over 35, what is the perimeter in units of triangle XYZ? They want you to know for this problem what tangent means. They want you to understand proportions in similar triangles. And they want you to know how to do the Pythagorean theorem and then what perimeter is. Those are the concepts for this problem. So first, tangent. The tangent of an angle, in this case angle X, the tangent is equal to the length of the opposite side over the length of the adjacent side. And when we talk about the opposite side, it's the side the angle is looking at. Like if you are overhead view, sitting at a table, and I am sitting here, I am sitting opposite someone over here. That's who I am looking at. The person here is who I am. My stylus is going wonky. That is a very unusual person indeed. This is the person I am adjacent to. I could bump elbows with them. So for that, the side that's adjacent to the x, the one that's bumping elbows with it, is this leg. And the opposite is that leg. Opposite and adjacent is always one of these two. It is never the hypotenuse. Hypotenuse being the longest side. It's always the two legs, the two shorter sides. So they're telling us the tangent is 12 over 35. Now, a lot of times on SATs, when they give us these tangents, sines, cosines, they're using the actual lengths of these sides. Here they're not, because they're saying it's 12 opposite over 35 adjacent. But we know the opposite side is not 12. It's 24. But we can go, hey, 12 times 2 gets me to 24. It's a ratio, so that proportion, if it was like a similar triangle, it's going to be the same. So 35 times 2 must be the length of this side, 70. Now we have the sides of a right triangle. We have two of the sides. We can use this with our a squared plus b squared equals c squared, Pythagorean theorem. So our two legs are 24 squared plus 70 squared equals c squared. When we add those two together, we're going to get here 576 plus 4,900. I wrote that really weird. To get 5,476 for our c squared. Then we can take the square root of that to solve for c, and we find that c is 74. Okay, now we have our three sides of this clearly not drawn to scale triangle. Perimeter is just adding the lengths of those sides together. So if I add these three sides together, 70 plus 74 is 144. 144 plus 24 is 168. And that is my perimeter of these, and that is B. That's my answer. So a lot of, different concepts. We've got the tangent, we've got similar triangles, those ratios, Pythagorean theorem, and perimeter all in one, but that's our answer, B, 168. 25. X squared plus 14x plus y squared equals 6y plus 109. In the xy plane, the graph of the given equation is a circle. What is the length of the circle's radius? If you want to try putting this into your calculator, graphing it, and seeing if you can measure the radius and then see which of these square roots it is equivalent to, I wouldn't recommend it, but yeah, that might work for you. Definitely worth a try if you'd like to. This method I'm about to show you, it is longer, it's a little more complex, but also for problems like this, it's more precise. And also there are some problems that show up on the SAT, especially in these later numbers, like the high 20s for the number of questions that are on the section and module, where this graph of a circle comes into play. Here is the equation for the graph of a circle. Its base form: x minus h squared plus y minus k squared equals r squared, where the center of this circle is hk. As you can see, that is the opposite of what's in the equation, and r is the radius. So when you are given something like this, it is not in this nice pretty format. We have to put it there, and we have to do that by completing the square. Yes, completing the square, that aspect of algebra that most people learn for the test and then forget and are like, oh, thank goodness, I never have to complete the square again. And then it comes back and goes, ha ha. Yeah, you do. It's a thing. It happens. Yeah. Yeah. Go completing the square. So to complete the square, I'm going to tell you the process, and I'm going to lightly reference why it works, but I'm not going to go into detail on how it works. I have other videos on that. If I am given this equation, I have x squared plus 14x plus y squared equals 6y plus 109. If you are tasked with converting this into this format, you want everything that has a variable attached to it on this side, all the constants on that side. That's the easiest. So I'm going to move this 6y over there, and I'm going to leave this 109 by itself, and that will accomplish that goal. So I'm going to subtract 6y from both sides. And now I have x squared plus 14x. I'm going to leave a gap. You'll see why in a minute. Plus y squared minus 6y. I'm going to leave another gap. Equals 109. Now I need to complete the square twice for these. You are trying to convert this. You're trying to figure out what number would go here so that then I could write this resulting trinomial as a perfect square of x plus or minus something squared. Now, if you remember this from factoring, if it was x plus a, I'm just going to use a to be a constant, x plus a squared, and you square this out, it's going to be equal to x squared plus 2 times a times x plus a squared. That's the pattern. So we have to create something here that has an a squared that it will go back into this formula. And it's important, this doesn't show up that often on the SAT, but just in case it does, I would be remiss if I did not tell you, you cannot do completing the square if there is anything in front of the x squared. I mean anything, a negative, 2, 3, a quarter, a half, I don't care. Any number, any fraction, any negative sign, you cannot have anything in front of the x squared and still do completing the square. It just won't work. So, x squared plus 14x blank. What you're going to do, and again, it has to do with that. I just said that x squared plus 2ax plus a squared. More in a video I'll link below if you want to know exact details. To find what a is, you take this number, including that plus sign, and you divide it by 2. That's it. You divide it by 2. Here it's a positive 14. So my a is going to be a positive 7. 14 divided by 2 is 7. Then the number that goes here is your a squared. So 7 squared is 49. And now this right here, x squared plus 14x plus 49, is equal to x plus 7 squared. Now I just added 49 to the left on the left of this equation. Let me get rid of these little extra lines there. I have to add it over here to the right to keep things balanced. Okay, now I'm going to repeat what I just did with the y's. Okay, so I am going to bring down my little plus. I want y plus or minus something squared. I'm going to take this negative 6, the middle constant. I divide it by 2. Negative 6 divided by 2 is negative 3. Then I square it. Negative 3 squared is positive 9. And again, I have to add that 9 to both sides. So now y squared minus 6x plus 9 is equal to y minus 3 squared. That is true. On the right, I need to combine these things. 109 plus 49 plus 9 is 167. So now I have an equation that looks like, dun, 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 the equation of a circle. X minus h squared plus y minus k squared equals r squared. So this 167 is my r squared. So r would be the square root of that. So the square root of 167 is my r, and that is C. Again, I don't think I've ever tutored a student who likes completing the square. It's so common for students to just forget it as soon as they finish it. Like, oh, never again. And then it keeps coming back, keeps coming back. So, it's good to learn. It is. I know it's not fun. But yeah, completing the square, and our answer is C, square root of 167. 26. The speed of a vehicle is increasing at a rate of 7.3 meters per second squared. What is this rate in miles per minute squared, rounded to the nearest tenth? Use that 1 mile equals 1,609 meters. Now there's an aspect in this that I think can be a little confusing when it says meters per second squared. This does not mean meters per second squared. It means meters per second squared. Meters per second per second. So yeah, when you're doing this conversion, anytime you're doing a rate conversion, you're wanting things to cancel out. So if I just wanted to do a straight conversion, let's say, of miles to meters. If I had 50 miles and I wanted to convert that to meters, I would say, okay, 50 miles over 1. I want to multiply by a ratio where miles is on the bottom and meters is on top, so the miles cancel out. So here, 1 mile, the miles are going to cancel out, is equal to 1,609 meters. So if I do this math now, I will have meters. That is how unit conversions work. When you have multiple units in the same thing, you have to convert every single unit. So you multiply by multiple things. Okay, so I have 7.3 meters per second squared. So it's 1 second times 1 over 1 second. Okay? That I think is the easiest way, because it's second times second. 1 second squared. So to convert this, I need to multiply by, I need to convert this to get to miles per minute squared. All right, so I don't want any seconds, I want minutes squared. And I also don't want meters, I want miles. Okay, so I want the meters to cancel out. Currently there's a meter on the top over here on the left, so I'm going to put my meters over here on the bottom. 1,609 meters for every 1 mile. Then to get these seconds to disappear and to get minutes squared, I'm going to multiply by saying there are 60 seconds in 1 minute. And again, there are 60 seconds in 1 minute. I'm just writing ratios that are true because I want to be able to do this math and have all the unnecessary or unwanted measurement terms to be gone. So now second times a second is gone because it's second times a second up here. They've canceled out. The meter is gone because it's down here. And what am I left with? I have miles on top, miles per minute times minute, miles per minute squared. So if I multiply this, 7.3 times, about my 7.3 times 1 times 1 times 60, all that on top, and that is going to get me 26,280, and then on the bottom, 1 times 1 times 1,609 times 1 times 1. I divide by 1,609, and I'm going to get 16.3, and then it keeps going, but they don't want any more than the first 10th digit, so it's going to be just 16.3, which is B. Again, I think the biggest part of this is that second squared. I think a lot of students are going to multiply either not enough or too many times and get the wrong answer here, but that is the proportion I think is the easiest to understand way to set that up. I think in the answer for this one, they had it as, they did the ratio as 3,600 seconds squared is equal to 1 minute squared. I think that's what they had in the answer key, if I'm recalling correctly. I don't know. That's not a ratio that most of us have on top of our head. But I think, we've learned that 60 seconds is 1 minute, so I think it's easier to visualize that way. Your mileage may vary. I hope that was helpful. Answer is B, 16.3. All right, last one in this section. Number 27, y equals negative 2.5 and y equals x squared plus 8x plus k. In the given system of equations, k is a positive integer constant. The system has no real solutions. What is the least possible value of k? All right, my strategy for this, first I'm going to visualize what's going on here. Y equals negative 2.5. That is a horizontal line that is going through, let me draw this little, let's go purple for my graph. I am not using the graph in the background. I am just sketching here. This is not drawn to scale. I'm just trying to visualize in my head what might be going on. All right, I'm visualizing y equals negative 2.5, so that is a negative line, a horizontal line down here at y equals negative 2.5, okay. And I know that y equals x squared plus 8x plus k, that positive x squared tells me it's a parabola opening up. Now they also tell me the system has no real solutions. They don't cross. When you have a line and a parabola, there are three options. There could be two solutions where it goes like this, and you have 1, 2 solutions. There could be one solution where it goes down, just touches it, and there's one solution. Or there can be no solutions. And this applies whether it's opening up or down, because then it would be 2, well, 1, and none. Doesn't matter. This one happens to be opening up. So, all right. I know it's somewhere up here. I'm just going to draw a little parabola. All right, so I know that there's this parabola, and it does not touch this line, y equals negative 2.5. And I go, okay, k is a positive integer constant. What is the least possible value of k? What's the smallest number I could put in for k that would drop this so low, that would drop this parabola so low that it's almost touching that line, but it ain't quite doing it? All right, what is going to be the lowest point on this parabola? It's the minimum. The minimum is right on that vertex. The axis of symmetry goes through it. Whatever this parabola is, the vertex, that's going to be the lowest point. It's at that minimum point. So I want to find out what's the equation using k and what I'm given. You know, k if it's involved, I want to put it in there. What is the equation for the vertex, or I should say not the equation for the vertex, excuse me, the equation for the line that goes through the vertex, that is the axis of symmetry. This equation, and it's so good to know, it comes up a lot and it's so helpful, is negative b over 2a is equal to x. There you go. Done. Like how straightforward is that? Nothing really fancy. It's not like the quadratic formula. And what are those a and b constants? They are the numbers. A is the number, if any, in front of the x squared, that constant. B is the number, if any, in front of the x, the plane x. And so that negative means take the opposite of whatever that b is. Okay, so we have a positive 8. The opposite of that is negative 8. And then 2 times a. My a is an invisible 1, so 2 times 1 is 2. 8, negative 8 over 2 is negative 4. So I'm like, okay, I'm adjusting where this equation is in my head. I'm like, okay, so it's a parabola. It's over here somewhere, and it's going through. The axis of symmetry here is x equals negative 4. Negative 4 is where the vertex lies. All right, I'm going to give myself a little room. Rewrite it over here, y equals negative 2.5. All right, so this is the visual I have in my head. I can sketch it on paper like this if I need to. That's totally fine too. Now, what is the least possible value of k? I know that this equation, this parabola, has to be above negative 2.5. It has to be greater than negative 2.5. So that's how I'm going to write it. X squared plus 8x plus k, squeaky desk, is greater than negative 2.5. And I know this minimum point, this lowest point, is at the point where x is equal to negative 4. So I'm going to plug in negative 4 for x. Negative 4 squared plus 8 times negative 4 plus k must be greater than negative 2.5. Let's do this math and figure out what k needs to be. Negative 4 squared is 16. 8 times negative 4 is negative 32. Plus k must be greater than negative 2.5. 16 plus a negative 32 is negative 16. Combining those. Now to solve for k, since it's minus 16 or negative 16, I'm going to add 16 to both sides. So on the left, I just have my k, and greater than negative 2.5 plus 16 is 13.5. So k has to be greater than 13.5, but we were told at the very beginning it is a positive integer constant. So what is the smallest, the least possible value, the smallest positive integer constant that is greater than 13.5? 14. And that is my answer. K must be 14 for its least possible value. And that's it. We're at the end. You made it. Congratulations. Hey guys, the full insanely comprehensive SAT math prep course I've been promising for so long is live right now at mathwithalyssa.com. And of course, you can also still get the free 10 video course on SAT tips and tricks at mathwithalyssa.com as well. You also can now book one-on-one tutoring sessions with me. Links to how you can do that are in the description and the pinned comment below. And as always, if the video you just watched was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.